fellow assassins, to another episode of the Dark Assassins Podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. Now, one of the biggest parts in any software development project has got to be the loops. We go round and round through our data structures, through our arrays, through pretty much everything. Loops play an integral part in any kind of software development, and it's probably going to be one of the first things that you learn how to do aside from Hello World. And it's, probably because, when you're writing code for the first time and you're manually typing out all these additions and subtractions and various operations on stuff, it gets pretty old having to type the same line 10, 15, 20 times in a row. So why can't we just automate that process with a loop? So we're going to get into that in this episode, getting into the various kinds of loops and then some kind of little variations on each kinds of those loops, and kind of getting into when you should use them, should you even use them in the first place. So that is coming up in this week's episode. But before we get into that, let's start off with our trivia question. Now, I know some of the trivia questions have been rather tough, so I figured this week I'd give you guys a little bit of a layup. At least I hope it's a layup, but I guess we'll see. I guess you, the listener, can be the judge if it is or not. But this week's trivia question is actually multiple choice, adding to the layup appeal of this question. So, what type of connector does the standard Cat6 Ethernet cable use? Is it A, RJ11, B, serial, C, RJ45, or D, MPO? And that is your trivia question for the week. Now, before we get into the cybersecurity tip, I was browsing some cybersecurity news, and let's just say I hope people out there aren't using VMware right about now, or if they are, they have applied their patches, because there was two pretty severe security vulnerabilities recently that would potentially exploit, basically an exploit that would allow you to bypass authentication and have remote code execution. In other words, pretty much the worst case scenario. So these flaws occurred with VMware in the ARIA Operations for Networks section of VMware. There have been patches that have been pushed, so make sure if you are using VMware, you update so you don't be affected by this anymore. But basically, what was said about the attack specifically is a malicious actor with network access to an ARIA network or ARIA Operations for Networks could bypass SSH authentication to gain access to the ARIA Operations for Networks command line interface. And obviously, if you have access to the command line interface, you can basically enter whatever commands you want on that interface and basically do whatever you want. So definitely pretty severe. It makes sense that it scored a 9.8 out of 10 as on its severity score, rightfully so, I would say. And then there was another one where there is a vulnerability where you could arbitrarily write data to a file, and that could basically had to have some arbitrary code execution. So this obviously ranked pretty high too. But arbitrary code execution, while it can be very, very devastating for sure, it's not quite as bad as, someone has a direct command line interface into your system, because then they have free reign to do whatever. Whereas if they have arbitrary code execution, potentially they could be a little more limited. Although I would say in a good number of cases, if you can get arbitrary code execution to happen, generally probably what you're going to try to go for is you're going to try to have your arbitrary code do an exploit that would then give you a remote shell into the system, so then you can do whatever you want. Now, obviously, there are some potential limitations to that. Trying to get that to happen can sometimes be a little bit challenging, depending on how the vulnerability is executed, what permissions you have on the system, and other various security measures in place like firewalls and whatnot. So it is, which is why it general arbitrary code execution scores a little bit lower on the vulnerability scores. But nonetheless, still something you don't want to have happen. So definitely if you're running VMware, the affected versions are VMware ARIA Operations Networks, version 6.2.3.4, 0.51, 0.6, 0.7, 0.6, 0.8, 0.9, and 0.10. So obviously you want to update if you are running any of those. And they say that the new version 6.11 is supposed to fix both of those flaws. So if you have not already, definitely want to make sure that you update that. And that is a great segue into this week's cybersecurity tip. So we just talked about different exploits, remote code execution, and total command line access and whatnot. And that's something that I wanted to bring up in this week's cybersecurity tip. Specifically, you should pen test yourself. And when I say pen test yourself, it might sound weird, but companies do this all the time. It's pretty standard practice. Basically what it is you hire someone, or in the case of you can just do it yourself. But in the case of companies, when they do pen tests, they'll hire some cybersecurity firm or something to come in and try to hack them, whether that's do phishing attacks, whether that's trying to gain unauthorized access to spaces, whether that's trying to compromise accounts or hack systems, whatever the case may be. There's a lot of stuff that goes into it, but basically the point is to find vulnerabilities and patch them, because obviously the last thing you want is to be going about your day. You come back from a hard day's work at the office or at the supermarket or from school or wherever you're coming from, sit back, relax, open up your computer, try to log into your home lab, and realize that the entire thing has been absolutely obliterated because an attacker got in through an open port on one of your systems that was going to an IoT device, and then they did some jumping around, some lateral movement, and completely wrecked your system and your entire home lab. So that's obviously not something you want to have happen. So it's good to do periodic tests of your security, your system security. So things that you can try to do to pen test yourself is basically just try to break stuff. Try to break as much as you can by, see if you can't subvert authentication mechanisms, see if there's maybe some account on a system that you have that you didn't realize you had, or you forgot you had, and has a weak password that someone could potentially get into. Checking for open ports on your firewall is a big one. And obviously this doesn't specifically only apply to your home lab, right? It applies to like all your software that you're running too. Like if you're running any kind of software, that could potentially have, something exploitable in there that an attacker could exploit. Web browsers are maybe surprisingly or not surprisingly, depending on who you are pretty common for vulnerabilities like that for an attacker to, exploit. Now, some other things that you also want to do for software related is your own software. So if you write your own software, you want to be testing it for vulnerabilities, checking for the basic stuff like buffer overflows or integer overflows and that kind of stuff, stack overflows, as we'll discuss later. So there's other things that you can test when it comes to your software that you write personally, but it's just, just general good cyber hygiene to try to break stuff and hack your own stuff, because if you can do it, you can bet that some hacker, attacker, cyber criminal out there will be able to do it also. And one of the best ways that I think you can protect yourself is to make sure you can limit who even gets access to your network in general. So one thing that you can do is you can run different kinds of scans on your network. So there's this one tool out there by Gibson Research called Shields Up, which basically just kind of does a scan of your network, your router, or whatever, the front-facing interface from your local area network to the wider internet. And it does just a basic scan of universal plug-and-play ports just to see if anything responds. Generally, you don't want any response, or you want rejections for that. So that's something to look for. If you have something be accepted, an accepted connection, you probably want to look into that. But that's a super easy thing to do. Another thing you could do is if you have some kind of server in the cloud or something, or at a friend's house or somewhere where you're not home, one thing you could do is you could do some kind of port scan on your home network. If you know your IP address of what your home IP address is, you can do a port scan on that with like Nmap or something, and kind of do a port scan, see if there's any open ports, because if there are, hopefully you know what they are and they have a reason to be open, because as we said, you want to make sure that you don't have a bunch of open ports on your firewall. So that's another thing that you can do. And just in general, just trying to see if you can't break into things, whether that's bypassing things or just entering bad input that'll cause the system to act in undefined behavior, allowing you to do some arbitrary code execution, perhaps. So definitely some things that you want to keep a lookout for, and that is your cybersecurity tip for the week. Now, before the nerdy things, I saw another interesting article this week, which I didn't necessarily even realize this was a thing, but apparently Visual Studio is being retired for the Mac. So Visual Studio will no longer support Mac OS, which it's... For context, that's different than VS Code. VS Code and Visual Studio are two different things. Visual Studio is like the full-blown, development environment, generally for Windows, more commonly on Windows. I'm not sure how many people that use Macs actually use full-fat Visual Studio. Maybe that's why it's being retired. But I do know a lot of people use tools like VS Code or VS Codium, which VS Codium isn't a Microsoft product, but it kind of is, because VS Code is an open source like IDE text editor thing that Microsoft produced, and then VS Codium is basically a fork of that removes all the telemetry garbage that Microsoft baked in to VS Code. But anyway, that's a whole different subject. But anyway, VS Code or Visual Studio for the Mac being shut down. So they say that Visual Studio 17.6 will continue to be supported for another 12 months. So come end of August of 2024, it will no longer have support. So I guess if you're one of the few people that are using Visual Studio for Mac OS, I guess you have a year to find something else. So yeah, I'm not really sure why people are. I don't really know what the use case is. I guess if you're trying to build apps for Windows on a Mac, then maybe that's useful. Doing any kind of like .NET stuff, which is, I think, generally more Windows-based. But I guess more tailored to if you're doing like anything kind of Windows-based, but you're using a Mac. I guess that's why you would use Visual Studio, but who's to say? I don't know. I just thought that was interesting. Kind of caught me off guard. So I was like, wait a second. Does anyone actually use Visual Studio on Macs? But apparently, I guess they do. I guess that would be kind of like if Apple decided that they were going to stop support for Xcode on Windows, except the catch there is Xcode isn't even available on Windows, so it's not really even an option in the first place. But at least that's kind of how I see it, since Visual Studio is kind of like Microsoft's integrated development environment, and Xcode is Apple's version. And you're not only limited on Visual Studio to build Windows apps, you can build like cross-platform apps. And similarly on macOS with Xcode, you're not limited to only building iOS apps or macOS apps or tvOS apps or anything like that. You can also build other cross-platform apps or just use it as a basic IDE, integrated development environment, code editor type thing for other languages like Python or C or C++ or basically anything else. So just something I thought I'd bring up. And with that, let's get into what nerdy stuff have I been up to this week. So I think we should probably start with the derp moment I had this week, which was I was trying to do a test of my 10 gig connection on my NAS. Now, I had never really done a good test of it to actually see what kind of speeds I would be able to get on my NAS with the 10 gig card installed, because it's the only device on my network that has a 10 gig card, so there's really no way for me to saturate it unless I tried to do like 10 simultaneous connections at the same time, which would be a little challenging. But in lieu of that, I did try to have multiple servers connect to it all at the same time and try to download and upload a file and try to see what kind of speeds I was able to get. Now, obviously, because all of those devices would only have a 1 gig connection to the NAS, they would only be able to achieve speeds of a gigabit per second. But in theory, the NAS should be able to handle multiple of them all connecting at their full 1 gigabit speed per second, because obviously the pipe, going to the NAS is 10 gig, whereas only 1 gig pipes are going through. So in theory, I could have 10 simultaneous connections at 1 gigabit before I experienced any sort of bottlenecks. In theory. In practice, that didn't happen. So I tried 2 different servers on my network and tried to connect over the 10 gig connection. And I started the first connection up, and it was running at the full gigabit speed, as you would expect. And then I connected the second one, and the speed was cut in half. So both connections to the NAS were each around like 50 to 60 megabytes per second, or basically half a gigabit. And I was like, why is this happening? I should not be bottlenecked. I have a 10 gig link here. I should be seeing, like 120-ish megabytes per second on each one, to fully saturate that, gigabit link that they got going on, maybe a little bit less because of the overhead of the network protocol or whatnot. But I should be seeing significantly faster speeds than this. So what the heck is going on here? So after troubleshooting for a little bit, I realized how dumb I was. Because you see, I have two switches in my home lab in my rack. The one switch is a pure gigabit switch. It only has gigabit ports on it. The other switch also has gigabit ports on it, but also has two 10 gig ports on it, which is what my NAS is connected to. Now, it just so happened that the two devices that I was trying to connect to the NAS with were both on the sole 1 gigabit switch. And that 1 gigabit switch connects to my switch that has the 10 gig link on it through a 1 gigabit connection. So while my NAS was capable of handling up to 10 gigabit, it was bottlenecked by a 1 gigabit pipe running between it and the other switch where the two servers I was trying to connect to the NAS was on. So imagine you have... So I guess in theory it doesn't matter if you have a bucket, that's a really wide bucket if you're trying to fill it with a single hose. Because it doesn't matter if you have, gallons and gallons of water all connected through different hoses if they're all inevitably going through the same hose to get to the bucket, right? Now, if they were connected to my other switch, it would essentially be like pouring all of those different buckets through individual hoses all into that bucket, so it'd be able to fill up quicker. But obviously that didn't happen because I was bottlenecked over the single 1 gig connection between the two switches. So that is where my issue arose. So then after doing some reconfiguration and adding 2 more servers into the mix that were all on the switch that had the 10 gig link aside from one, ran the test again, and wouldn't you know it, I was seeing like 450-ish or something like that megabytes per second of read and write speeds on my NAS dashboard. I could see the network traffic, and oh man, it looked so nice to be able to see all that speed going on. And it oh boy, just seeing all the so I had 4 terminals open for each of the servers I was logged into to do the download and upload test, and seeing all of them simultaneously fully saturating a gigabit link while my NAS wasn't even at half capacity was absolutely incredible. So obviously I didn't fully saturate and test the 10 gig connection, but having to run 10 server connections all at once to try to connect to that would actually be kind of a challenge, because while I have more than enough servers to do that on, my main problem is the majority of my servers are virtualized, meaning they all share a single port on the host machine, right? So if when you're talking about a virtualized operating system, if you have, say, on my Dell R620, my absolute workhorse powerhouse, the core of my home lab, currently only 4 of its, well, I guess technically it has 6 gigabit ports because it has an external PCI card with 2 other ports, but I'm not using those. I only have the 4 kind of, I guess, integrated ports, if you will. So 4 ports. So that means collectively it could, process 4 gigabits worth of speed in and out, right? So if I wanted to fully saturate it, I could only have 4 servers on that one machine, and they'd all have to be using a different port as their bridge out to my network. because otherwise I'd run into the same issue that I had with two servers on a 1 gigabit switch sharing a 1 gigabit link to my other switch that has the 10 gig link, because I'd be bottlenecked by that single 1 gig pipe. Even though theoretically I should be able to get more, I'd still be bottlenecked by that single 1 gigabit pipe. In this case, it'd be the one port that multiple virtual machines are trying to go in and out of. So I'd be bottlenecked there. So that is one, I guess, downside of virtualizing basically everything, is you have to make sure that if you truly want to have all of your virtualized devices have maximum bandwidth, you need to make sure you have the networking capabilities on your server to accommodate that. Now, probably the easier solution would just be to hook a 10 gig or plug a 10 gig card into my R620 and basically route almost all my traffic through that. Then I could have way faster speeds, but whatever. So it would be surprisingly kind of a challenge for me to actually find 10 servers that are on individual ports that could actually all connect uninterrupted to the NAS to actually saturate the 10 gig link. Plus, not to mention the fact of having all those terminal windows open, although I guess I probably could find a way to automate it with Ansible, which is probably how I'd actually end up doing it anyway, if I did try to do it. But nonetheless, seeing that massive transfer speed was a sight to behold, because I don't think I've really ever seen network speed transfers that fast, or at least that much collective speed. So it was definitely a sight to behold, and that was definitely the highlight of my day when that happened. And other stuff I did, I've been talking, I guess, the past couple weeks now of my C implementation of my encryption algorithm, and that's basically done at this point. I mentioned I got basically almost everything implemented last week aside from directories and multi-threading. Well, directories and multi-threading has been implemented at this point. The only thing that's really left to do is make it a little more nice looking, I guess you could say, and also actually implement user input when it comes to multi-threading, because right now it's pretty much if you want a multi-thread, you have to edit the source code and recompile, which obviously is not ideal. So that's something that I'll have to add either a user prompt for or maybe a command line flag. I haven't fully decided on how I want to go about doing that. And the other thing too is I haven't fully decided how I want to go about implementing it, if I want to try to be smart about it and try to determine on the fly if you should actually multi-thread or not. Because part of the problem is, sure, there's a couple things you can do, right? You could do an approach of how many files am I actually trying to encrypt or decrypt, and if it exceeds a certain threshold, then go ahead and do it. But the problem you run into there is you're basically taking a greedy approach when it comes to your selection, because you might only be encrypting or decrypting, say, 5 files, but if each one of those files is like a gigabyte or 2 gigabytes worth, I mean, you probably should have multi-threaded that thing so you could have all of them being encrypted or decrypted at once rather than sequentially. But on the other hand, do you really want to take the time to parse all of those files and see how big they are in order to determine if you should be multi-threading or not? Because at that point, you're going to get the best solution of should you multi-thread or not, but at the same time, you have even more overhead trying to get the file sizes and all the logic involved of trying to determine if you should multi-thread or not. So should you just take the user at their word and say that they want to multi-thread, even if potentially it might cause a hindrance to their performance? Now, personally, I'm kind of on the mindset of I'll just let the user decide, and if they want to in the theory of C, right? I'm implementing this in C. I might as well take a page out of C's book and let the user shoot themselves in the foot if they so desire. Now, obviously, if you multi-thread, encrypting, say, like 2 files when it'd be faster if you didn't multi-thread, in all reality, you're probably not going to notice it at all. You'd only really notice it if you put like a timer before and after like the encryption and like took it down to like the microseconds or nanoseconds or whatever and saw the difference. But in the human perception, you'd hit enter and they'd both be done almost instantly. So like, you're realistically not going to notice. So I'm probably just going to end up taking the user at their word. Although one thing I have put in there as a hard stop is not allow the user to add more threads than they have files, because at that point you're just literally wasting resources. Because if you only have, say, 5 files that you want to encrypt, but you say you want to run with 10 threads, you really can't do that, because at least how my encryption algorithm's designed, it has to go sequentially. Now, you can do multiple encryptions in parallel, but a single encryption has to go sequentially because of how you're doing essentially XORing each of the individual blocks. So you can't easily like chop up a file and partially encrypt it. That's just not how the algorithm works. So you're basically just wasting resources spinning up those extra 5 threads that you're never going to use. So I do have a hard cap of saying if you're only, going to be encrypting or decrypting, say, 5 files, you're basically capped at 5 threads. So even if you enter in like 10, the number of threads that would actually run at would be 5. So it just caps it like that. So that is one thing that I did decide to put in there. Now, in addition to that, I also mentioned the user interface. Now, currently, it's only command line based, and I'm going to keep it that way. I'm not going to put any kind of GUI on there. And the reason why I say it needs improvement, because in true me fashion, is it pretty? Absolutely not. But is it functional? You bet it is. So I do want to at least try to make it a little more aesthetically pleasing. It maybe, even if it doesn't actually look any prettier, just like space some things out so it's not like a jumble of text that you kind of have to manually parse through. So that is something that I do need to work on. But that's kind of all like fluff stuff, I guess if you could say. It's not really like necessarily super critical to how the program functions, because functionally it's done. It's just a matter of making it a little more user-friendly, I guess. So someone that isn't the person who wrote the code can actually have a enjoyable experience, or not a painful experience, I guess you could say. Because if there's one thing developers are terrible at, it's writing intuitive user interfaces for non-developers and non-tech savvy people. So if you ever see because chances are, if you see a horribly designed user interface, there's a decent chance that program or that app is one heck of an app that is super amazing under the hood, but the developer just had no sense of how to make a good user interface, because if he's like me or she is like me, we're not good at that stuff, which is why there are literal teams in the corporate world specifically designed to create the user interfaces. That's not the developer's job. They'll have like a separate like UI development team that builds the user interfaces to make it more intuitive for non-developers and non-tech savvy people. So yeah, so there is some work that has to be done on that. Now, one thing, a little bit of a transition here. If you've listened to the podcast long enough, you know that I have quite the obsession with the Apple Xserve and the Xserve RAID. It is quite an obsession that I have. And it seems like every couple months or something, I come up with something else to do to bring it up. And yet again, I've done it again. I'm bringing it back up. And I actually have a good reason to this time. There hasn't been any new developments. I mean, obviously the server line's been dead for over a decade now, well over a decade. But I have some new developments. So if you recall back, I believe it was in June, I was really proud of this walkthrough that I did of going through how to actually use the Xserve RAID as like some kind of NAS solution or just a storage solution in general. Kind of even wrote up a whole blog about it, and the massive amount of power that it sipped. Well, I guess I shouldn't say sipped, like it downed power in the neighborhood of basically drawing more than all the power of my home lab combined just by itself, sitting there doing nothing. But anyway, one thing that I wanted to do when I initially went down that rabbit hole of, trying to manage it and set it up and configure it and all that stuff was a better way to handle the management software. So, as a little bit of a recap, the Xserve RAID has a management tool called RAID Admin. And this is a Java application that was designed by Apple in order to manage the Xserve RAID. Now, theoretically, because it's a Java application, you could run it's platform agnostic. So you could run it on a Mac, you could run it on Windows, or you could run it on Linux or BSD or anything that you could install Java on. Theoretically, you should be able to run the RAID admin software. In practice, though, it didn't really work unless you were using a super ancient operating system or ancient version of Java. Now, if you're not super inclined to Java's history, there have been a lot of exploits with Java, in large part, I think, because people will download and install Java, and then they basically never update it. But regardless, like any program or software, it has vulnerabilities. So using an old version of it from a cybersecurity perspective is not smart. So you obviously don't want to be running this RAID admin software on your main machine, because in order to do it, you have to have a super old version of Java installed, which, as I mentioned, is not smart. Your other option is to use an old operating system that, I guess, the version of Java that is needed for RAID admin was natively supported on. Specifically, I think the version I was testing was macOS 10 Lion, which was like 10.7.5, I think was the version I was using. And in that case, when you try to install RAID admin, if you don't have Java installed, it'll actually install the correct version of Java that you need, and everything will work fine. But again, you have two problems here. One, you're using an old unsupported operating system, and two, you're using an old outdated version of Java. So two not good things. And the other thing of it too was I didn't want to have to boot up my Xserve into its Lion install every time I wanted to manage my Xserve RAID, which granted was basically never, but still, or I'd have to bust out my black 2007, I think, MacBook that's running macOS 10 Lion anytime I wanted to use the RAID admin software. Again, not ideal. So I knew, in theory, I could somehow containerize it or put it in a virtual machine or something, and my goal was to get it in a Docker container. And I couldn't figure out how to do it, and I kind of let that project simmer on the back burner and kind of I guess forgot about it or kind of didn't really. Occasionally I'd come back to it and try to like look into it a little bit, but nothing ever came of it. But then this week I actually had a breakthrough and I actually got it working. So now you can run RAID admin and manage your Xserve RAID in a Docker container that you can spin up and spin down at your leisure whenever you actually need to connect to and manage your Xserve RAID without actually having a massive security vulnerability lying around. So I was super happy and been pumped about that. And initially when I first got it working, I ran into the same issue that I did when I tried to I guess, hack my way to get RAID admin running on macOS Ventura. That is to say, I was able to get it to run, but when I would try to connect to the Xserve RAID or literally do anything, the program would crash. So then I had to go to an older version of Java, and then that inevitably fixed the issue. And the thing that made me really jump up and down was when I had the Xserve RAID plugged in and connected to the network, had the Docker container booted up and was connected into it through VNC, which is basically a remote desktop protocol. And I added the server or the RAID, Xserve RAID to the administration software there, and then right-clicked it and hit power on, and the Xserve RAID booted up. And I was like, yes! That was such a big win. And then I was able to, navigate through all the menus and check the status of everything, and it was awesome. So that's something I had been wanting to do for a while and finally got it working. So if any of you out there are as crazy as I am and have an Xserve RAID lying around and you want an easy way to manage it, well, now there is a Docker container with a Docker Compose, so you can just do an easy Docker Compose up, navigate to your server through VNC to get access to the RAID admin, and then when you're done, Docker Compose down, shut it all down, and you don't have to worry about security vulnerabilities. So I was super happy and pumped about that. Of course, I don't know if I mentioned this or not already, but of course, up on my GitHub, as most of these awesome projects that I talk to you guys about like this, up on the GitHub, so anyone that wants to use it or whatever, more than welcome to. So with that, I think it's about time we get to the meat and potatoes of the discussion that I wanted to have today, which is on loops and the different kinds that you'll use and encounter when writing software. So there's really I would say there's three main kinds of loops, and one of the most obvious. The first two are obviously the most obvious, that being for loops and while loops. And then the third one is a little bit of a dark horse, I guess, if you will, and that is recursion. And I would say it's kind of a dark horse because recursion is its kind of own separate thing where it works in a loop in the sense that it keeps going and going and going until a certain end state is met, in which case it stops. So in that sense, it's kind of like a loop. But it works differently, where rather than iterating through, say, a number range or while some condition is true, you're basically calling the same function over and over and over again until you reach a certain base case. And then at that point, you start going backwards, back up the loop and getting back to where you came from. But we're getting a little bit ahead of ourselves. So let's start out with the basics, which is the for loop. Now, when it comes to the for loop, there's a couple of different, I guess, variations, if you will, of the for loop. You have your standard range-based for loop. So if you're doing a Java or like a C, C++ type thing, that'll be like your for int, variable equals whatever, less than equal to, whatever, that kind of a thing, or it's within a certain range. And then you'll have other kinds of for loops, which are like kind of, sometimes they'll be like iterative based for loops. So certain data structures like in C++ will have iterators for them. So rather than having to write a a for loop, you can use the iterator to iterate over the vector or the map or whatever the case may be. And then you have other things that are more object-based for loops. Generally, that they're kind of called like for each loops. So basically, I think this is pretty darn common in like Python. If you're trying to iterate over something, you'll say like for file in files or for line in lines, and you basically take rather than taking an index of, say, an array, you basically just take the element. So when you're working with inside the loop, you don't necessarily have to say files sub x equals something. You can say file equals something and do your operation that way. So it can make it a little more readable using for each loops. And it is a pretty convenient way, although depending on what your use case for the loop is, that might not necessarily be the best solution, because depending on the language, if you want to modify the variables as you're looping through them, for each loops might not be the best idea, since depending on the language and whatnot, they can be like their own instance where it's literally just the value. So, and then once it goes out of scope, or once it goes to the next element in the loop, any changes you made is just gone, so they don't stick around, in which case you would want to do like a range-based loop where you could actually access the specific element in whatever data structure that you were trying to work with in whatever case. So that is one thing to consider when working with for loops. And then going to the other common kind of loop, the while loop. This is generally more conditional based. This is where you if you ever want an infinite loop, generally people use the while loop, although you can have the same effect with a for loop as well. You just make it so that the end condition is never met and it'll just run infinitely. The easiest way to do a for loop in that case would be like for parentheses, colon, close parentheses, if you're using like a C, I guess, style language, and that'll just run infinitely. Or if you make the silly mistake of doing a reverse for loop, and that is to say you start at what your max value is and go to the smallest value, but rather than doing something like minus minus, you do plus plus just out of habit, and you just start incrementing upward. And obviously in that case, you're never going to reach the base case, so you're just going to keep looping forever. So there are ways that you can loop forever with a for loop, but generally the while loop is usually what's used for infinite-based loops. But that's not all while loops can be used for. They can generally be used for other conditional things that aren't necessarily, I guess, numbers-based, if you will. So if you wanted to see when a certain value was equal to something, or if you wanted to check if like there was a certain modulo value, basically if there was a factor of something, you could do while loops for that. One common thing that I like to use while loops for, specifically do while loops, which are a branch of while loops. They're basically the same thing, with the key difference being a do while loop is guaranteed to run at least once, where a while loop is not guaranteed to run at all. So, for instance, if you want to check, if your while loop condition is, say, if a value is true or not, and that value is already true before it gets to the while loop just won't execute. But if you have a do while loop, it'll execute once through the while loop before it actually checks to see if the condition is met before exiting the loop. Now, personally, I like to use this kind of loop when dealing with user input, because obviously I want to prompt the user at least once, and then potentially subsequently multiple times if they give me bad or wrong input, prompt them again for the actual correct input. So that's generally the time I use do while loops, although they also have other use cases as well. But now I guess we can get to the fun stuff. Depending on how you look at it, fun could be a very sick definition of this, but recursion. Now, recursion is kind of I guess the rite of passage, I guess you could say, when it comes to software development, because it's not easy. It's very easy to run into Stack Overflows, and not the website, the actual Stack Overflow where you overflow the stack for your program. Now, we'll get into how that happens here in a little bit, but generally speaking, recursion is viewed as more challenging because in the way that you execute it. Now, I kind of alluded to this in the beginning, but recursion works by calling the same function over and over again. So there's a couple things you have to be mindful of. Any kind of values or variables that you want to have their value retained through each loop, you have to pass in as a variable, because obviously, unlike a for loop or a while loop where you could put a variable outside the loop and then modify it through the loop as needed, you can't really do that with recursion unless you make like a global variable, because every time you get back, you call that function again, it gets reset to that value that you want to, have access to through outside of the loop. It just gets reset to whatever you default it to. So it's not really going to work. And the other thing you have to really keep a watchful eye out for is you really have to nail your base cases. And what I mean by your base cases is the case in which the function will actually return itself and go back up to the version of the function that called it, so it can then return itself and go back up and so on. So if you forget an edge case and you run into an edge case, that's where you keep going infinitely and you overflow the stack and your program crashes. So I guess we talked about overflowing the stack, and Stack Overflow. So how does that work? Now, obviously, Stack Overflow, it works based on HTML and JavaScript and CSS and all that stuff because it's a website. I'm joking. Although technically, that the website version, sure. But the actual Stack Overflow that we're talking about here is similar to the buffer overflow. So I've talked about the buffer overflow a decent amount on the podcast. And basically, as a refresher, the buffer overflow is where you set a maximum length for, say, a string or a character array or something like that in, say, C, and then you write more data to it than you have allocated. So let's say you allocated 64 characters worth of memory and you write 128 characters to that 64 characters worth. Obviously, you wrote more than you allotted to, so you overflowed your buffer, and that's the buffer overflow. So the Stack Overflow works basically the same way, except with the stack. Now, the reason why recursion can cause stack overflows is because how the operating system handles function calls. Now, when you call a function, under the hood, what's going on is the operating system will load that function onto the stack. And the stack is just another part of the system's memory that gets allocated for your program. So, and every time you call a function, that function gets added onto the stack. And then whenever your function returns and goes back to the main of the program, that, part of the memory gets cleared and you go back to where you were. Now, how recursion works is because you keep calling the same function over and over again, you keep adding more and more layers onto your stack, and it keeps growing and growing and growing until you get to the point where your operating system's like, you've used too much of the stack, you're done, and they cut you off and your program crashes. So that's how the Stack Overflow occurs, and you can crash your programs. So that's why recursion can potentially be harmful, and you really have to keep a watchful eye out for it and make sure you're hitting all of your base cases to make sure that your program always returns. But another thing you have to be mindful of is depending on what system you're using, like if you're doing programming on an embedded system, for example, that doesn't have ludicrous amounts of memory like, modern computers do, you really have to be careful with your recursion with how much memory they have, and potentially doing anything recursively could potentially just be an instant death sentence, potentially. So it is something you have to keep in mind. And also the scope of your recursion too, because while you very well might cover all your edge cases no problem, if your edge cases are so far down that you call the function so many times, you still might run into a Stack Overflow because you haven't met your base case yet and overflowed the stack. And an easy way to do this is by having too many local variables. So going back to Operating Systems 101 here, we mentioned when you call a function, it gets loaded onto the stack. And any variables that you pass into that function or create inside of that function also get added onto the stack. So this is why if you create, a variable inside of a function, it's not accessible anymore when you exit that function because it was on the stack. And then once your function returns, you go back to where you were, and that variable obviously is out of scope and is no longer accessible. So if your recursive function has a ton of local variables and takes in, massive things of data as arguments, like you're taking in entire classes as arguments, for example, or massive structs. This is where you can easily overflow your stack quicker by adding more and more data. Rather than just the function itself, you're adding tons of data along with said function, so you can overflow your stack even quicker. So it's something that you really need to keep in mind if you're thinking about implementing a loop or a function recursively, that you be mindful of the parameters that you're passing in and how much data you're allocating onto the stack, so you don't overflow your stack. But with all that said, recursion does have some pretty fantastic use cases. So anything that benefits from recursion, but what the heck does that mean, Sherlock? Basically, like if you're trying to, say, navigate any kind of directory structure, like if you're trying to navigate a file system, or if you're trying to navigate another data structure like a tree, or anything that kind of goes downward and has multiple branches that you can go to, that is an excellent use case for recursion. Basically, if you ever want to implement your own tree data structure, whether that's just a generic tree or a binary tree or binary search tree or any kind of tree, you're going to use recursion. So definitely something you should know how to do. And going back to the nerdy stuff I did this week, the encryption algorithm that I'm using in order to get all the files that need to be encrypted inside a directory, guess what it's using to get all the files in the directory? You betcha it's using recursion. So what it'll do is it'll go check the file, see if it's a regular file or a directory. If it's a directory, it'll call itself again and go through and check each file in that directory. If it runs into a directory, it'll navigate into that directory, check each of the files, and then once it checks all the files in the directory, it returns back the list of all the files in that directory, and then it'll, return the list of the files in that directory and so on until it gets back up to the root of the directory or the main directory that I passed in. So a fantastic use case for recursion right there, kind of like a textbook example of when to use recursion. So it does definitely have its use cases, but it is something that you really have to be careful about when you're trying to implement it. Another common use for recursion is the Fibonacci sequence is one of the probably, I can't say for certain, but I would say there's a pretty strong likelihood that the first program, like especially if you go through any kind of like academic curriculum, The first introduction you'll have to recursion is implementing the Fibonacci sequence through recursion. That's probably what it's going to be, because the Fibonacci sequence, it's a really good use for recursion. Now, you can do it other ways. I had an operating systems class in college that made me implement it with shared memory and pipes, which was absolutely terrible. I do not recommend, but it is up on my GitHub for what it's worth. So if you ever do have to implement that and you want some reference material, obviously don't copy it, but if you want some reference material, that is up there. But yeah, recursion. But for what it's worth, in order to check my program output when I was doing the shared memory and pipes version of the Fibonacci sequence, I was comparing it against the, I guess, normal way to do it, if you will, which is just straight up recursion. So recursion definitely can be a powerful tool, but also something that you have to watch out for. And there are some people out there that are strict, like no recursion ever. I'm never going to use it. I don't want to use it because of the memory implications involved with recursion, as I mentioned, with all the stack memory that'll be used up by it calling itself over and over and over again. But definitely something to keep in mind. Regardless of what kind of loop you use, they all have their kind of tailored use case. Although if you really, really want to try, you could honestly use any one for any problem that you want to solve. Like, you could use recursion for a basic for loop if you wanted to. Don't recommend, but you could. In the same vein, you could use a for loop for something that you could also do recursively. Now, that for loop would probably look absolutely disgusting and terrible to read, but I mean, you could do it. Same thing with a while loop. You could just as easily have a while loop where you set a variable outside of it, set it equal to 0, and then check if it's less than some value, and then at the end of the while loop you do like a plus plus or something to increment it and have it function the exact same as a for loop. So they're very interchangeable, but they also do kind of have things that they're more tailored to. So hopefully this little bit of a discussion on loops kind of helped you get some insight on maybe what loops you should use. Maybe it opened your mind to loops that you didn't know existed, or maybe gave you even more reasons to avoid one loop or the other. Regardless, hopefully you learned something. And speaking of learning something, let's get on to our trivia question to see if you knew the answer or not, or maybe you'll learn something else. I don't know. We'll see. So this week's trivia question is, what type of connector does the standard Cat6 Ethernet cable use? Is it A, RJ11, B, serial, C, RJ45, or D, MPO? Now, if you said A, RJ11, you technically are not correct. You're just not right. It looks like the Ethernet cable, but it's not. It's that cable that was used for like phone lines. So I guess technically you could make the argument that it was used for the internet at one point, like with modems and dial-up and all that good stuff, but it's not Cat6 Ethernet cable. So I'm sorry. But if you said RJ45, then you are correct. So RJ45 is the connector that the standard Ethernet connector uses. Cat6, 5, 6, 7, basically all of them. Now, as for the other two, the serial connection, that's more for, you generally don't really see those anymore. That's like your RS422, RS3232 type connectors. Generally don't really see much of those anymore. Sometimes you'll still see them on like enterprise equipment and like switches and stuff. So they are still around, but generally not super common, especially on consumer grade gear. And then the MPO, that's something that's in the fiber world. So I guess if you really wanted to be a stickler, that also could potentially do Ethernet, but not Cat6 Ethernet. So that was the trivia question for the week. Hopefully you enjoyed this episode and learned something. And if you did, I ask that you leave it a rating and review and subscribe to the Dark Assassins podcast if you haven't done so already. And this episode in particular, probably want to share it around since we went into some good stuff, did some good deep dives on loops, and it's specifically anyone that has an Xserve RAID. There's probably not many of you out there that are crazy enough to have one like I am, but if you do know someone, definitely gonna want to shoot them this episode so they can see the new Docker container that's out for that. But if you have any questions about this episode questions for future episodes or topic ideas, you can send me an email at contact@darkassassinsinc.com. The link for that's down in the show notes below. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.